Okay, we're back. Let's do the next lesson. The next lesson is arithmetic sequences. So the aim is arithmetic sequences. And so in the homework, you were asked to determine whether the terms in a sequence were actually a sequence, and to describe the sequence. And so in this class, we're going to be talking about two types of sequences. The first type is arithmetic, and the other type is geometric. And so with an arithmetic sequence, we're adding or subtracting to get to the next term, and a geometric sequence is when we multiply or divide to get to the next term. Now, this is really good. So now we can quickly see, we're going to talk about the arithmetic today. The arithmetic, so we saw in the last class with the recursive formula, we know that we have a u of n plus 1 is equal to u of n plus d. And that d is something called a common difference. Now, I'm also going to be giving you a formula booklet, because with IB, you get a formula booklet. You don't have to memorize these formulas. So, you'll see from the formula sheet, a formula looks something like this. U of n equals u of 1 plus n minus 1 times d. Now, this is the explicit formula. This will take you to the specific term. So let's take a look at this formula. So first we have u of 1. This is the first term. We have d, which is known as the common difference. This is how we jump to the next term. Common difference. We have u of n, which is the nth term. And we have n, which is the place. It's not the number, it's the place. So this formula is going to help us solve several questions. Yes, before we do that, let's take a look at these two formulas. So let's take an arithmetic sequence. How about 1, 4, 7, 10. So first of all, we know that this is U1, this is U2, this is U3, and this is U4. You might say, Mr. Adler, it's clear that it's arithmetic, and it's clear that we're going up by 3. Jump plus 3, plus 3. So you'd say, okay, the d is 3. A fancier way is that u of 2 minus u of 1 equals 3. And u of 3 minus u of 2 equals 3. And u of 4 minus u of 3 equals 3. And so this is the fancy way of showing the common difference. What was the change each time? And that goes back to our recursive formula, which is simply u of n plus 1 is equal to u of n plus 3. Okay? That's it. So that's the idea of the common difference. We have this formula, and what can we do with this formula? Well, the formula, can everyone see that? Will help us answer several questions. First of all, it'll help us answer what is the nth term of the sequence. What is the nth term of the sequence. I'm lazy, I'm going to abbreviate. It will also help us what is the common difference right? And whether a term, or rather a value, is a term of the sequence. Now, before you even answer any questions, first of all, is it a sequence? Right? Ask yourself, what kind? And ask yourself, what is the common difference and what is the first term? So that's always going to help you. So let's say I give you a sequence, right? I say 3, 7, 11, 15, 19. Even before you start, you just say, okay, the first term is 3. I know it's an arithmetic sequence. I can see the common difference is 4, right? Like, get that information down. The second you have that information, all of a sudden, you can start filling in the formula. You can start answering questions. For example, the first question I'm going to ask you is, find u of 8. So you'd say, okay, well, take a second, u of 8. I want you to pause the video and see if you can find the 8th term based on this formula. So you'd say, pause. Okay, welcome back. You say, okay, that's fine. U of 8 is equal to u of 1 plus 8 minus 1 times 4. Well, we know u of 1 is 3 plus 7 times 4, and we have 31. Let's talk, how about if I ask you to find u of 20? Same idea, 3 plus 20 minus 1 times 4, that's 9, so that's 3 plus 19 times 4 is 76, and that's 79. You could use a calculator for this. Let's talk about this formula first, just a quick second. What's going on here? Well, the question, what is this formula? The way I look at it as, you're starting at 1, and to get to n, you have to go n minus 1 jumps, right? So to get from the first term to the 4th term, I have to make 3 jumps. So if I'm in position 1 to 2 to 3 to 4, that's 3 jumps. I asked you to go to the 8th place, right? So I'm at position 1, 2, 3, 4, 5, 6, 7, 8. That's 7 jumps, or n minus 1 jumps. That's how I view it. Let's move on. Is 51 part of the sequence? Is 51 a term in this sequence? What do you think? If it is, which one? Is it the, well, we know the 20th term is 79, and we know the 8th term is 31, so maybe it's between there. Any suggestions? Well, we're going to use some logic from last year. We're going to assume it is. Say, you know what? I'm going to assume yes. Right? That would mean that u of n, there's some n, I don't know what it is 51. And I'm just going to plug it into my original formula. So I'm going to say fine. It's the first term plus n minus 1 jumps, and the jumps are 4. Let's follow through. Let's see what our answer is. Well, you can either plug it in your graphing calculator. I will show you how to do that with and solve, but I'm going to do it a little old school. So subtract 3 from both sides, and we get 48 equals 4 times n minus 1. You can expand this out, or you can divide both sides by 4. So you know I can divide both sides by 4. I have 12 equals n minus 1, n equals 13. So 51 is the 13th term. Nice. Once again, I'm going to show you. I said you don't need to do this. If you want to do the algebra, that's fine. If you think that you're going to take SL analysis next year, you do need to know how to do this by hand. But if you know you're taking SL applications next year, I'll show you how to do it on the calculator. Let's move on. Here's another question. Ready? Ready for the next question? The 5th term of an arithmetic sequence, AS, arithmetic sequence, because I'm lazy, is 38. And the common difference is what? Is 3. So I have a couple of questions to ask you. I have a couple of questions. First, what's the first term? What's the 9th term? And I want to know, is 68 a term of this sequence? Okay, so find u of 1. How are you going to find the first term? Well, I have my formula. Use the formula. So once again, you have the formula. Always go back to the formula. Write this formula at the top of your sheet. Once again, and also, you're getting the formula booklet. So I know it's, u of n equals u of 1 plus n minus 1 times d. The unknown is the u of 1, right? So I know that u of 5 is 38. That's equal to the first term, which I don't know, plus I know there were 4 jumps, and the common difference was 3. Okay, 38 equals u of 1 plus 12. U of 1 equals 26. The first term is 26. What's the 9th term? Well, you could do it a couple of ways. You can say, you know what? I know to get from 5 to 9 is 4 jumps. So I'm going to do 4 times 3 is 12. Add that to 38. I get 50. Or you say, you know what? I'm using the formula. The 9th term, u of 9, is equal to u of 1 plus 9 minus 1 times the common difference. I know I just found the first term, 26, plus 8 times 3. Final answer, 50. And the last thing I asked you, is 68 a term of the sequence? Well, I don't know. Let's see. 68 is equal to 26 plus n minus 1 times 3, right? Okay, 68 minus 26. Oh, I don't need subtraction. Whoops, 42. 42 equals 3 times n minus 1. 42 divided by 3 is 14. n equals 15, so 68 is the 15th term of the sequence. Last question. And I'm sorry, I think I rushed that. This is fine the fifth term. Oh no, this was fine the first term. This next question was fine the ninth term. And this third question is 68 a term. Okay, the last question. I give you 5, 8, 11, 14. My question to you is, I know this is an arithmetic sequence, and you can see it's going up by 3s. So this is the first term, this is the second term, this is the third term, this is the fourth term. My question to you is, what is the first term that's above 100? Find the first term greater than 100. What do you think? What do you think? Take a second to think about this. You can keep adding up, right? A scenario might be you're having a party and you're handing out tickets. I just need to know after how many weeks 100 people, let's say you have a party and each week you're increasing the number of tickets sold by 3. I want to know after how many weeks do you finally sell 100 tickets? That's maybe the story. So, any suggestions? What do you think about it? Imagine you're working in groups, you're talking about this. Pause the video, come back. Okay, well, I'm going to assume that 100 is a term. So I use the formula. 100 is equal to 5 plus n minus 1, because I don't know what term this is. I'm assuming it's a term, I just don't know which term it is. So I have n minus 1 times, oh, by the way, what is the common difference here? Well, this is easy because it's plus 3. Okay, I'm going to solve, I'm going to use my GDC, or I'm going to solve by hand, so I have 95 is equal to 3 times n minus 1. 95 divided by 3 is 31.6, repeating, and so n is equal to 32.66. Well, that doesn't make any sense because I can't have like the 2/3 place, right? What does this mean? I want you to think about this. What could this possibly mean? How could 100 be the 32.66 term? Well, first of all, 100 is not a term. And the way I want you to interpret this number is, I know that u of 32 is less than 100, and therefore u of 33 is greater than 100. Once again, u of the 32.66 term is 100, which means the 32nd term is a little bit to the left on the number line, and the 33rd term is a little bit to the right. Therefore, the first term greater than 100 is the 33rd term. And then you can quickly figure it out. U of 33 is equal to 5 plus 33 minus 1 times 3. Use your calculator. 5 plus 32 times 3. 32 times 3 is 96. 96 plus 5 equals 101. You are going to do for homework, you're going to do 5C. You're going to do 1 through 4, 11, 12, 13. And for a challenge, you can do 5 and 6, but you could do all the other problems. Good luck.